Hey everyone, so this is video 6 and we're going to figure out how to do nomenclature. In other words, I'm going to stop this annotate for a second. In other words, how to name compounds. And where we're going with this is that in your packet, they ask you to write a balanced chemical equation for, mixing two reactants together, but they don't tell you the formula. They just tell you what the name is in English, and you're going to have to take that and convert it to a formula. Okay, so these are the rules for writing formulas, and we're going to start with ionic bonds. And as you recall, ionic bonds are formed between metals and non-metals, and there is a dividing line between metals and non-metals here. So this little staircase kind of tells you what behaves as a metal and a non-metal. And some of these that are right on the staircase are nebulous, they're semi-metals. I'll try not to, silicon can kind of go either way, but for the most part, metals are on the left or under the staircase. Lead is definitely a metal, and the non-metals are here on the right. Okay, so recall that ionic bonds form when one compound loses electrons, becomes a positively charged ion, another element gains electrons, becomes a negatively charged ion, and then they hang out together. And the purpose of that is to neutralize their charges, electrical neutrality. Remember that there are two goals that atoms have when they are forming bonds. One is to have a filled octet, filled energy level, 8 electrons in the outermost shell, although sometimes 2 if it's hydrogen or helium, and that they want electrical neutrality. So let's give an example. Let's say we're going to have potassium chloride, okay? So I'm going to write the words potassium chloride. Okay, first thing to notice is that the positive ion goes first. So that's the first rule that you need to know. The negative ion goes second when you're naming the compound. And we will change the ending of the name of the element that becomes a negative ion to end in IDE. And that's what tells you it's becoming a negative ion, because notice here, chlorine becomes chloride. If it were bromine, it would be bromide. Oxygen becomes oxide, nitrogen becomes nitride, and so on. Okay, so potassium chloride, we're going to look up the symbols. Okay, so we know that potassium is K, chlorine or chloride is Cl. And now we have to ask ourselves, what kind of ion is it going to make, or what's the charge? So here's how you find out the charge. This column right here is +1. This column right here is +2, because that's the number of electrons you need to lose in order to have a filled outermost shell. The noble gases do not form ions because they're happy as they are. They already have an outermost energy level of 8 electrons. This column right here called the halogens is -1. So fluorine, chlorine, bromine, and so on. Oxygen will make -2 and so on down the column, and nitrogen will be -3. In the middle here, these are called the transition metals. And also some of these guys down here. And these are like shapeshifters. They can form more than one charge, positive charge. And so we have to tell you. So for potassium, it's always +1. So it's just potassium chloride. This will be +1. Got to get my drawing tool back here. So that's going to be +1. This is -1. You crisscross the charges. We've done this before. And it's just going to be KCl. If you're going to form a compound with iron, iron can be +2 or +3. So the problem would have to tell you which iron it is. So let's say that I do iron, and you write that number in Roman numerals, iron 3 chloride. Iron is Fe. This 3 right here tells you that it's 3+. Chlorine is always -1 because of where it is on the periodic table. You crisscross the charges. And this formula is going to be FeCl3. Okay, other shapeshifters, manganese can be like manganese +4, manganese +7. It would have to tell you in Roman numerals. Lead can be lead +2, lead +4. It would have to tell you in Roman numerals. In either case, you crisscross the charges. If you have something like calcium oxide, calcium is always +2. Oxygen is always -2, and oxide, because it's the ion. You crisscross the charges, but they're both 2, +2 and -2, so they cancel. You can reduce that like it's a fraction, like 2/2 would be 1/1. So the formula is calcium oxide. Okay, so I'm going to stop right here. I'm going to call this ionic nomenclature, and I'll tell you about covalent nomenclature in the next video.